Welcome to this session. Today we're going to go over how can we create a GenAI application in an AWS infrastructure. So we will go through with the AWS in the video. We'll take through the entire process from deploying a GenAI model to creating an inference endpoint and building a static web application for verifying this endpoint using AWS Lambda and API gateway. Let us get started the step-by-step process of this. Okay, so introduction. Let's go this quick overview of deploying a generative AI model using AWS. This flowchart illustrates the sample process starting from the user accessing the web application hosting on Amazon CloudFront and stored in an S3 bucket. The user interface with the web app which send a HTTP post request to the Amazon API gateway. The API gateway forward the request to an AWS Lambda function, which process the input and invoke the SageMaker endpoint. SageMaker handle the inference request using the deployed model. The response is sent back through the same route, ensuring the seamless interactions. To update the large language model, simply deploying a new model to the SageMaker endpoint. The entire process is managed efficiently using the Amazon SageMaker Studio, ensuring quick update and robust performance. Before we deploying our GenAI model, it is essential to set up the right environment. Ensure we have the AWS account and the necessary performance to create a manage resources. Install the AWS CLI and configure it with your credential. So additionally, you will need to set up an S3 bucket for storing your model data and an IAM role with the required permission to access the AWS service securely. So this is actually a prerequisite for creating the to start with the SageMaker Studio and environment to start the endpoint deployment and inference deployments. So let's look at how the reliable model deployment. Now that our environment is ready, let us deploy the GenAI model. We will start by uploading our pre-trained model to the S3 bucket. Next, we will use Amazon SageMaker to create a model endpoint. This involves specifying the model location in S3, choosing the appropriate instance type, and configuring endpoint settings. Once deployed, SageMaker will provide an endpoint URL that will use for inference request for sending the user input. With our model deployed, the next step is to ensure create an inference endpoint. These endpoints will allow our application to send data to the model and receive prediction. We will use the SageMaker endpoint URL created earlier and set up an API gateway to act as a front end for our endpoint. This step provides a RESTful interface for an application to interact with the model, ensuring secure and efficient communication. Yeah, so let's look at the S3 bucket static application. We'll build a static web application to interact with our inference endpoint. We'll use HTML, CSS, and JavaScript to create a sample front end that will allow user to input the data and be model prediction. This web application sends HTTP request to our API gateway, which will then forward the request to the SageMaker endpoint. The setup ensure a seamless user experience for interacting with our GenAI models. Yeah, so then the GenAI AWS application and Amazon S3 bucket serve was the primary storage for the static web application. It securely stored all the static content such as HTML, CSS, and JavaScript files. When a user accesses the web app, CloudFront fetches the content from the S3 bucket, ensuring high availability and reliability. S3 scalability and durability make it an ideal choice for hosting a web application, enabling efficient storage and quick retrieval of web access on a seamless user experience. Yeah, in this architecture, Amazon CloudFront plays a crucial role in delivering the web application to user with a high performance and a low latency. CloudFront caches the static web content stored on the S3 bucket, ensuring rapid access for users worldwide. When a user accesses the web app, CloudFront retrieve the content from the nearest edge location, minimizing the latency and providing a seamless user experience. This efficient content delivery network optimizes the speed and reliability of our web application, enhancing overall user satisfaction and experience. So the new to change the LLM in a new model handles quickly deploying it as a SageMaker endpoint. So that's way if you have a new model comes out, I think you can deploy quickly. This SageMaker infrastructure will allow a seamless model update. So to enhance our application functionality, we'll integrate AWS Lambda. Lambda function will uh, handle the data processing and request routing between our web application and the SageMaker endpoint. We'll create a Lambda function that receives the request from the web app, process the data, and send to the endpoint. The function will then handle the response and return the prediction to the web applications. Testing and verifying the inference endpoint. Testing is a crucial step to ensure our inference endpoints are working correctly. We'll use tools like Postman to send test requests to our API gateway and verify that the response from the SageMaker endpoint. Additionally, we'll perform end-to-end testing with our web application to ensure that the entire flow from data input to model prediction is functioning as expected. Debugging any issue at this stage is vital to ensure that a smooth user experience. Yes, so with everything up and tested, we are ready for the final deployment. We will deploy our static web application to an S3 bucket, configure the static website hosting, and additionally, we will ensure our API gateway and Lambda functions are properly configured for production. This will final step to ensure that all the components of our applications are live and and accessible to the user in a scalable and fashion across the globe, and they will able to give the user input and get um, inference from the endpoint. So in summary, we have walked through the setting up a AWS environment, deploying a GEN-AI model, creating an interface, inference endpoint, building a static web application, integrating with the Lambda, and performing testing and the final deployment. The best practices include thorough cost analysis, feature proofing your infrastructure, choosing a reliable vendor, or also leveraging automation and continuous monitoring of your system. These steps ensure scalable and efficient deployment of your GEN-AI applications. Thank you for watching. If you have any question, please feel to ask the comment. Reach out through any to any comment you can update. Also, for such further such learning, we can recommend you subscribe to our channel. Stay tuned for more of this AWS additional GEN-AI application presentation from this channel. Thank you again for attending the session.